Hi, welcome to the class. Today we will do theoretical portion where I tell you one use of potentiometer, and in this use of potentiometer we are going to compare. We are going to compare the EMF measured by this potentiometer of two different cells. So we will be having two different cells. We will measure their EMF using the potentiometer and then we will compare them. As you all know that this device potentiometer is preferred over a voltmeter to measure the EMF, not the voltage, right? Because this potentiometer measures the EMF as it does not draw any current from the cell, right? So let us see. So this is the diagram. So here you can see this is the battery which provides the current to this potentiometer. Now potentiometer is this like 100 centimeter long wire attached on a wooden scale. So this is the wire. Now which material, this wire is made up of which material? So the wire is made up of manganese and constant turn, right? So this manganese and constant turn are the alloys with which this wire is made up of. Now this is the battery which will act like a power supply for this potentiometer. So since this battery is providing power supply to since this battery is providing power supply since this battery is providing power supply to this potentiometer, therefore it does not draw any current from the cell whose EMF it will measure. Now positive of this battery is connected to one end, and remember the positive of the two cells whose EMF we have to compare is also connected to the same end. It means positive of the battery, positive of the two cells are connected to one end. The negative of these two cells are connected to a two-way key. This is a two-way key. So we will decide which cell will come in the circuit depending on which key you tapped on. So suppose this key you tapped on, so E1 will come in circuit. This key you tapped on, E2 will come in the circuit. Then this key, the other one end of the key will be connected with a galvanometer, and then this galvanometer will be connected with a jockey J, right? Now here, the negative of the battery is connected to negative of the ammeter, and one end of the ammeter is connected to rheostat, and then with the help of a key, it will be connected to the other end of the potentiometer. So this is the diagram. As we all know that this E is equals to KL. What is K? K is the potential gradient. What is potential gradient? The word gradient means change in potential. Why I am using this potential? Because this is potential gradient. Change in potential with respect to the length. So as the length of this wire will change, there will be a change in potential. We are talking about the potential drop. Remember, this potentiometer works on the principle that the potential drop is directly proportional to length. Whatever potential drop is taking place across the wire, that is directly proportional to the length. Why length? Because we know that as the length will increase, resistance will also increase, and therefore the potential drop will increase. So E is equals to KL. K is the potential gradient. Now, if when this is tapped on, when this key is tapped on, E1 will come in the circuit. Using the jockey, we will find a null point. Null point, that is the balancing length. L is the balancing length. Length at which galvanometer shows no deflection. Length at which galvanometer shows no deflection. That will be balancing length. So in that case, we will do it experimentally also. So E1 is equals to K L1 will be equation. L1 I will know. Practically I will know L1. This will be equation number 1. Similarly, I will do it for E2. So E2 will be equal to KL2. This will be second equation. Now you will be knowing E2, L2 also, because the same process you will follow. You will find the balancing length on this wire, and the point at which galvanometer shows no deflection will be the balancing length, right? Now you know L1, you know L2, and you want to compare E1 and E2. Compare means taking out the ratios. So you will divide 1 by 2. So it will be E1 by E2 is equals to KL1 upon KL2. So this K will go off. So this E1 by E2 will be equal to L1 by L2. So that will be your, in this manner, L1 and L2 you will already know by doing this practical, and also if you know L1 and L2 doing this practical, then dividing these two you will get to know E1 and E2. So that is how you are going to compare the EMF of two cells using potentiometers, right? Thank you.